I will only show the inner cylinder, the part that is now voided out. And you will see how I set current source around that cylinder. So in order to add a current, you go to Field Dynamics, Fields, Current Distributions, right-click, Add Current Distribution, Distributed Current. Just going to call it Distributed Current. Description. Distributed current used to excite the pillbox. So now you can see that it sets a very large geometry here. This is the current that it sets by default, which is way too big for what we want to do. By unselected, we want a current going from this side, say all the way down to this side. To get a better view, actually, instead of a solid, I'm going to show you the geometry as lines. It can be seen even better when you want to see the void inside of the cavity. So you can see how the inner cylinder was subtracted. So now that we have the edges of the cylinder and we can see inside of it, we can add our current. So our current will be going in the y direction. So if green is the y-axis, it'll go from one top to the bottom. So I want to assign the spacetime function I defined. So current STF in the y direction. 0, 1, and 2 for the j's stand for x, y, and z direction. I've assigned parameters for these particular dimensions. So I want X-min to be X-min current, I want X-max to be X-max current, and same with all the other coordinates. And now you can actually see that this piece of geometry, it's actually not a geometry, it's the current, but it looks like part of the geometry. That is our new current, which goes inside the metal. I don't want to see lines anymore, I want to see solids. So it goes from one side of the cavity all the way through the other. Let's reset the position, so it goes from plus y to the minus y location. And that should be enough for us to run our simulation, but let's add also a history.